Alright guys, welcome to this page of the notes, and now what we're going to do is we're going to begin to take a look at our second objective, which is going to be simplifying complex rational expressions. And the reason that they're complex is because now we're going to begin to multiply and divide rational expressions. So let's just quickly kind of refresh ourselves on how you multiply and divide fractions from middle school and see how that sort of corresponds to what we're going to be doing here in Algebra 2. So if you remember back to middle school, what happened was when you multiply the numerators and the denominators when multiplying fractions. So the example I gave you is 5/6 multiplied by 4/15. Now, again, what I would actually encourage you to do is this. We multiply the numerators and we multiply the denominators. 5 times 4 is 20, 6 times 15 is 90. However, before multiplying, remember when it comes to fractions, you can do what we call sorry, that's my highlighter. Let me find my pen. We can cross cancel. We can cross cancel. So what we're going to do, or what I would encourage you to do, is actually first recognize this. The 5 and the 15 are going to reduce themselves, right, to a 1 and a 3, right, 1 and 3. And the 6 and the 4 and the 6, well, they're going to reduce, if you, right, factor out a 2, they're going to reduce to 2 and 3. So then what I wind up with is this, 1 over 3 times 2 over 3. Now I multiply numerators. 1 times 2 is 2. 3 times 3 is 9. And by cross-canceling first, I get the exact same answer as what I did above, but because I cross-canceled first, the answer I get is already going to be simplified because I will have already gotten rid of the GCF that the numerator and the denominator have in common. When it comes to division, remember from middle school, that division is multiplication by the inverse or by the reciprocal. In fact, in middle school, you may have learned that little phrase, keep it, change it, flip it. That's essentially what we're going to be doing here, just doing it with rational expressions instead. So I've got an example for you here as well. Let me highlight this guy. Multiply by the multiplicative inverse or the reciprocal of the divisor. And here's what that means. If you have 3 over 7 divided by 9/14, again, another way of writing that, right? 3/7, divided by 9/14. So then the sort of that phrase from middle school, keep it, change it, flip it, means you keep the top fraction, leave it the way it is, 3/7. Keep it, change it, the division gets changed to multiplication, and then flip it. You take that denominator, 9/14, you flip it to the reciprocal, 14/9. Again, at this point, I would encourage you to cross-cancel first, in which case the 3 and the 9 would reduce to a 1/3. The 7 and the 14 would reduce to a 1 and a 2. And then what I actually have is 1 over 1 times 2 over 3, which of course is 2/3. I get the exact same answer that I got here just by cross-canceling. Once I do my multiplication, I am already simplified. But the point is this. In order to multiply the numerators, multiply the denominators. In order to divide, we will multiply by the reciprocal of the denominator. So let's try a couple of these now using rational expressions and sort of after having brushed up a little bit on what you guys did in middle school. So I give you these two rational expressions, 4a divided by 5b multiplied by 15b squared over 16a cubed. Again, multiply the numerators, multiply the denominators. But I'd cross-cancel first. So here's what I can do. 4 and 16. Well, that's going to reduce to a 1 and a 4. The a in the top will cancel with one of the a's in the bottom, right? I have an a up here, 3 a's down here. That a up here will cancel with one of the a's here and leave me with 2 a's left over. So this now becomes an a squared, right? That's now an a squared. Okay, that takes care of that cross canceling. The other direction, well, 5 and 15. That'll cancel to a 1 and a 3. And then the b here, right? 1b down here, 2 b's up here. Well, this b down here will cancel with one of the b's up there and just leave me with a b up there in the top. So that guy goes away, and then I'll just get rid of that exponent, leaving me with a b. So here's my new problem. Everything over here canceled, leaving me with 1 over 1. So 1 over 1 multiplied by, well, I have a 3 and a b left over. 3b all over. I have a 4 and an a. Well, 1 times anything is just that number. So I wind up with 3b, 4a, but don't forget, I still have a denominator, and since I have a variable, I will need to restrict my domain. A cannot be 0. And there you go. You have used what we learned in middle school for multiplying rational numbers, multiplying ratios, applied it here in Algebra 2 to rational expressions. Hopefully you can see the parallels between what you did in arithmetic and what we're doing here in Algebra 2. It's just what we're doing here is slightly more complicated because now we are putting in these rational expressions that have variables and even in a little bit polynomials. But let's keep going. I got another one for you here. This time we'll do division. Well, here's what that means. We are going to multiply by the reciprocal. So I will have 4x squared y over 15a cubed b cubed. Change the division to multiplication and flip the second fraction. 5ab cubed over 2xy squared. Again, when it comes to division, you multiply by the reciprocal, or for middle school, it's the keep and change and flip. But I keep the first fraction, change division to multiplication, flip the second guy. Well, cross-canceling, again, I would suggest doing first. That way, when I multiply these guys together, I'm already simplified. So let's do that. 4 and 2, absolutely. Those will reduce to a 1 and a 2. The x in the bottom will cancel with the x in the top, leaving me with 1x left over. The y in the top will cancel with the y in the bottom, leaving me with just a y down here. All right, let's go the other way. 15 and 5. Well, the 5 will cancel, leaving me with a 1 and a 3 for that 15. That a in the top will cancel with one of my a's in the bottom, leaving me with an a squared. And look at that, b cubed in the top, b cubed in the bottom. Those just completely cancel each other out, go away. And so here's what I'm left with. I'm left with a 2 and an x, so 2x over. I'm left with a 3 and an a squared. 3a squared multiplied by, well, 1, the a went away, the b cubed went away, so it's just going to be a 1 left over up there in the top. And then in the bottom, 1, everything else canceled except for that y, so that leaves me with a y. And we go ahead and multiply those guys together. Multiply the numerators, well, 2x times 1 is 2x. 3a squared times y is just 3a squared y, and restrict the domain, where a cannot be 0 and y cannot be 0. And again, there's only one set of restrictions because the variables are multiplied, right? Because those variables were multiplied, the only restriction is a can't be 0 or y can't be 0. You can pick anything else you want. And I don't have to worry about the x. I'm sorry, I'm getting, pen's going crazy. There we go. I don't have to worry about the x because I don't have an x in the denominator. All right, guys, hopefully that makes sense. Head on over to the next page of the notes. We'll try a few more of these, practicing the cross-canceling first and then multiplying our rational expressions. I'll meet you guys over there.